Alright guys, so Scatterplot and lines of best fit worksheet. So just going over this, you do have the printable link linked in today's assignment if you want to go and print it and then come back and start this again, because these are great notes. So the Scatterplot shows the number of CDs in millions. As I've said before, make sure you're reading what's on your X and what's on your Y axis, because that's one of the ways that they'll stump you up on your EOC. This was sold from 1999 to 2005. If the trend continued, about how many CDs were sold in 2006? So basically, we're looking for one more dot. This is a negative correlation. So we know it's negative. It's pretty strong because it looks like they're very close together. It's pretty close to our line that we could sketch. So it's a strong negative correlation. Now, we could use actual coordinates if we wanted to go plug this into our equation, but if we were making a good guess, it looks like about right here, they sort of flatlined. We went down to the next one, a little bit down, but it's a pretty close, minus this guy right here. He got a little out of control. We went back up, and then it would be again about 10. So in 2006, it looks like we'd get somewhere between 650 and 700 if we kept going. So maybe about right there, or maybe a little bit higher. Now, something could go astray, and it could be really wild, and it could do something crazy like 2003 went a little offline. Or actually, I guess, depending on what you're looking at, because this looks like a pretty good line going this way too, and then it got real high up. But you want to go straight down the middle and make a good prediction. So about how many would be somewhere between 650 and 700 would be my guess. And even if we followed this line, it would still between 650 and 700. So between 650 and 700 CDs is about, because it says about here. So it doesn't have to be super, super accurate in that question. Number 2, the table below shows the predicted annual cost for a middle income family to raise a child from birth until adulthood. Draw a scatter plot and describe that relationship, what the relationship exists within the data. So we know our age is down here at 3 is 10,000. So this is in thousands here. 10,700. So we're going to go up to 10, which is 10,000. And 700 would be just under 11. So there. And then 6 is 11,700. So we're going to go up to 11, because remember, these are in thousands. And then pretty close up to 12. And then 9 is 12,600. So 12, maybe just above half. Then for 12, it's going to be 15. Jumps up a little bit up there. And then at 15, it's 16,700. So we're going to go all the way up here to right here. So discussing that correlation, if we're assuming that it's linear, it is going to be a positive correlation because it's increasing to the right. It's a positive correlation. And then I would call it fairly strong because it's really close to a line. It's not perfect. It did a little jump up here, but for the most part, we could draw a line that got really close to all of those points. It doesn't have to be perfect because, again, we're just making a generalized statement about this data, but maybe I could get a bunch of dots right there, and even on either side of that line, they're pretty much equally spaced on either side. So that means it's a strong positive correlation, again, because it's going up to the right. Number 3, make a scatter plot of the data in the table. Draw a line of best fit. What is the equation of the line of best fit? So we're going to plot our points. So -2, +2, -2, +3, -1, 2, 0, 1, 1, 0, 1, 1. Oh, I about messed up. 1, -1. Okay, good. That one happens too. 2, -1, 2, -2, and 3, -2. Hopefully you see that these are going in a linear pattern this way, a little bundled. They're pretty tight again. You could sketch a loose line in here, but what I'd like you to do is actually watch over here in Desmos. We are going to work in Desmos because a lot of you reached out and said you didn't have your TI, your 80, your 84s and 83s. Sorry, I was having a moment right there, trying to figure out where we're getting our table. So we're going to go to our X1, and we're going to type in all our X values. So it was -2, and then whoops, that's a positive. -2, -1, 0, 1, 1, 1, 2, 2, 3. And then we're going to go put in our Y values, which should be 2, 3, 2, 1, 0, 1, -1, -1, -2, -2. And it's plotted just like the one we did on our paper, so that's awesome. Then you're going to go into your second line here, and we're going to type y, and we want to go down, so y down 1, y1 is going to be, and then, oops, this is in my way. Let's see if I can move this thing out of the way. Your squiggle bar should be over here. If I'm not mistaken, I remember correctly in the ABCs. Ugh, this guy's all in the way. All kind of in the way. Sorry, guys. ABCs, squiggle, MX, and again, that's going to be that 1, 2, plus B. Now, so that means that we have, this does our correlation for us. So our correlation is our R again. Our M is -0.96. So our slope is a -0.96, and our B is 0.78. So as your line that you would want to use for predicted values, so our actual is plotted as green dots, and then our black is our predicted line. But so you can answer questions about future values. If I do f of x, and you're doing f of x so it knows for Desmos that we are discussing this function, equals, it's a -0.96x, and then plus 0.78. And that's going to get our line. It's on top of the one they gave us. We do see that it is a strong negative correlation because it's close to that $-. So it's a strong negative. I'll make that one go away. And then if we go right here again, and we come up here to our toggle or our gear, I can hit table underneath this function. And so if I wanted to know anything in the future, whatever this data, like maybe I want to know what the predicted value for 6 is. So I can go right here and I either erase this, or I can go down the bottom, put in a 6, and the predicted value would be -4.98. Or if I wanted to know what the predicted value based off this data is for 10, it'd be -8.82. So you plug in, but you have to put this in to be able to get your table. So again, you're going to type this in, hit your gear. It'll give you the option to get a table, click the table, and then you've gotten it right here. And it will take whatever numbers you have here in your table, you will see as red dots right here. It'll graph them for you. So that's the perk of Desmos. So as far as what is your equation of line of best fit for this line, that is that y equals, and we got these numbers from right here. Let's see if I can get this done. Go away. Right here. And we got them from up here, our M value and our B value. So 0.96, and it's a negative, x plus 0.78. And our R value is at -0.93, which means it's a strong negative correlation. So that means the data does relate to each other very strongly. And it's just going down from left to right, so that's why it's negative. Number 4, the education table at the right gives the number of hours spent studying for a science exam and the final exam grade. Draw a scatter plot of the data and draw in the line of best fit. What is the equation of line of best fit? So instead of graphing it here, I'm going to go back over here to my table. See if I can clear the whole thing. Yep, so if you go up top, delete. We got to make sure we put a 1 back if you do that. Oh, it's still going to make me do it. All right, so we're just going to delete each one. We're going to go on top of them. So we have 3, 2, 5, 1, 0, 4, 3, and then delete. All the way through. Oh, it didn't let me just go on top. Oh well. Okay, so 3. The output for 3 was 84. The output for 2 was 77, 92, 70 at 1, 60 at 0, 90 at 4, and 75 at 3. Now, this is our new line. This is the original one, so we're going to get rid of it. So we're going to ungraph it. Ungraph the points, ungraph the line. So that one's no longer a conversation. That was to our last problem. So now we have our problem here. We have our M, so our slope is 6.31, and then our B is 62. So you can change your graph, like what you can see here. And all those data points are actually way up here, which you can see your green dots are your table. So it's a positive correlation again. It looks pretty strong to me, which because they're close to that line, which is correct because looking at our R value, it's a 0.9556 or 0.96, which is very close to $1. So again, using that information, you can answer all kind of questions, but most importantly, if we write what is our line of best fit, it's going to be y equals, and our m value is 6.31, so mx, and then plus 62.05, because there's an 8 after that 4, so we want to round it up. Our correlation coefficients are R, so determining whether this is a strong amount of data or not, we'll say 0.96. So it's going to be strong because it's close to $1, and positive because it's positive. Predict the grade for a student who studied for 6 hours. So I can go right below this again, and I'm going to type in my equation, which we get from that data like we just wrote. We're going to use f of x equals, and it's going to be 6.31 x plus 62.05, and again, that's coming from the data right above it. So we have that equation in there, and we're going to go right here, and we're going to come up here and hit our gear, and we'll see there's a table, so we'll start a table. The question was for 6 hours, so I can delete this and hit 6, and my answer is 99.91. So the answer for 6 is 99.91 right here in our output. So the predicted grade for a student who studies 6 hours would be a 99.91, which if we're being honest, that's probably a grade of a 100, so about a 100. Could this line go on forever and ever? Is it going to infinitely continue to go up? The more you study, will your grade infinitely go up? Probably not, because most grades max out at 100. Not saying that's for everything, for every class in the rest of your life, for the rest of the universe, but most classes at 100 is the highest you can get. So basically after 6 hours, you're probably going to stop. We can put in a 7 in our table and just to see if it actually makes it better, but most of you are not going to make 106 unless teacher obviously offers you some bonus points. But logistically, 6 hours is probably the maximum amount of study time based off of this data necessary for this work.